Hi and welcome back to a new video. On my table we have the INNO3D RTX 5090 iChill Frostbite. And before we even start into the video, I want to make clear that this is a potential conflict of interest, because this card is equipped with an alpha-cool water block. And INNO3D is also aware of this, that we are working on water blocks with thermal grizzly. So there's definitely potential for a conflict of interest. I will still try to be as neutral as possible. I just want to make this clear. I also talked with INNO3D about this topic. They're fine with it. I'm also fine with it because we also tested these cards in the past and they were always great, especially if you consider that you want to get a water-cooled card with a cooler pre-installed with warranty. Those cards were typically a very good option. So I want to test what they did with RTX 5090. You need serious power for demanding workloads? Then check out Hetzner, one of Germany's largest internet service providers. With its own data centers, high-performance servers and storage solutions, Hetzner provides the digital foundation for projects of every size. They also have VPS options with dedicated vCPUs that are perfect for massive data processing, machine learning, gaming servers, websites and high workload applications for super low prices. With the code DEBAUER15, new customers can even save $15 or €15. Find out more in the link in the description below. This card is a sample, which also explains why you would already see water inside the card, even though I personally didn't use it yet. And they also already posted a teaser news about this card, reporting about that the card is equipped with a 600 watt power targeted BIOS, like by default, which I think is interesting. And they also reported about that they had issues with the 12-volt high power connector reaching 150 degrees Celsius on this card. And that's stuff I want to observe and also obviously afterwards disassemble the card. I think they didn't do it because the card, according to Hardware Lux, is equipped with the Honeywell phase change pad, and it would probably be bad to disassemble the card and just put it back together. But that's all stuff I want to observe or just test in today's video. As I said, the card comes with this alpha-cool core block pre-installed, but it's a special version directly for INNO3D, which you can see by firstly the INNO3D iChill logo on here, and also in the center. They have this, I don't know what they call it, maybe somewhat like a distribution plate or something like that. But on the normal block, this reads core, what the alpha-cool core series is called. And here, this is also the INNO3D Frostbite logo. They also marked in and out. It's a bit difficult to see, but if you pay very close attention to here, then you can see an in marking and an out marking if you're interested in the flow direction. But you can also kind of, make up for that yourself by just looking at how the flow is going on that block. So it goes in here, in the center, and then spreads out to the side and flows back here. And on the bottom right here, we should have an RGB strip installed. The back side or the back plate of the card is also customized to the INNO3D design. You can see, again, powered by INNO3D, so no alpha-cool branding on there. It's an aluminum back plate, anodized. And what I was just wondering about is what this means. I can't remember that I've seen this anywhere on any other card. It says use only with listed ITE host. ITE, I think, is information technology equipment or something like that. But I don't really understand why this is there or what it means. If you have any clue what it means, please let me know. The terminal can be used from the front and from the back side. It is generally made of plastic, but it has those inserts, and I think they should be nickel-plated brass. And that's, the way we know it from AlphaCool. That is well executed, especially if you think about, acrylic terminals, and if you are not familiar with the amount of torque you could use, then it's easy to crack those acrylic terminals. So this is very good that we have those brass inserts. In between the backplate and the PCB, you can see some thermal pads. That means that the backplate is also used for cooling, or at least spreading the heat between the backplate. Not sure how much the backplate itself can actually cool, but it's definitely used for spreading the heat. GPU is in place, and I will now also use a WireView Pro in our new 90-degree version, which has a very limited compatibility. So for the most air-cooled cards, it's not compatible because of the fact how the 90-degree connector sits on this side. That means that whenever you have a card where this is a little bit recessed, it usually doesn't fit, but it fits perfectly for water-cooled cards like this. And what I wanted to point out is that it also has external temperature sensors apart from the internal ones. TA and TB. So two of these sensors can be attached. They are included. And I already mounted one between the thermal pad and the back plate, so we are able to monitor the back plate temperature also under load. Already looks quite nice. The flow rate, as you can see, is about 145 liters per hour, and the water temperature is at about 22 degrees Celsius, but it's also not under load yet. I'm pretty sure you have seen the WireView before on my videos, and in this Pro version, it is automatically cycling through the view, so you can see like average power consumption, total energy consumed while the WireView was connected, and also the different temperature sensors. You can also manually click through, and then it will stay for 60 seconds and at that view that you selected, and then it will switch back to the cycling mode to just decrease the burn-in on the OLED display. But here you can see the voltage that is coming from the PSU. You can see the current power draw, the amps, and also the temperature. Here we have T in and T out. That is the temperature of the power connectors. T in is the one on the bottom, and T out is the one that is attached to the GPU. That's why also T out is usually a bit higher. And here you can see TA and TB. Those are the optional temperature sensors that you can connect. TA is currently not connected, and TB, I thought, makes sense, temperature backplate. I'm currently running 3D Mark Speedway for maybe like 20 minutes to figure out what kind of temperature we should expect from this card. And then I was observing the power draw on the WireView that is reported. And we typically see something about 600 watts, in this case even 620 watts, that are being pulled over the 12-volt high power cable. And then I thought, okay, that's interesting, because if we look at GPU-C and the reported board power draw, which should be the total power consumption of the card, this is more in the range of 560 to 590, mostly 570, as you can see. And the 12-volt high power cable is a little bit less, because we have a little bit that goes over the PCI Express slot, but it's like 5 to 10 watts. And you see, yeah, that's quite a bit different. We see about 550 to 570 over the 12-volt high power cable, according to what GPU-C is telling us. And that is quite a bit different to what we see reported over the WireView. And I thought, which one is correct? So this one is reading 610 right now, so 600 to 610. The other one is reading 550. Then I thought, okay, I'm just getting the current clamp on the 12-volt wires, and you can see currently between 50 and 51 amps that are being pulled over the 12-volt rail, and like 50 amps with 12 volt equals 600 watts. Oh yeah, I mean 50 amps in this case is the max, but yeah, you can see it's 50 amps roughly. So the WireView is actually closer to this. I'm not sure why we see this difference, but when I hooked up the current clamp to here, I noticed that the coil whine on the card is changing. That is something I also didn't observe before. That is interesting. I will now attach my microphone to here and not talk, and then you should be able to also hear the difference. And it's also only when I close the current clamp. So if it's measuring, and if I open, it's a lot less. This kind of current clamp that can measure both DC and AC current usually works with a Hall effect sensor in there. And this is measuring the magnetic flux density. And the magnetic flux density is depending on the amount of current that is flowing through the wire. And this, the current is introducing a magnetic field around the wire. And this is then picked up and translated into the current. And my personal guess would be that adding the current clamp on there is just changing the magnetic field around the wire, and this is then somehow impacting how the coil whine sounds like. That is a very interesting phenomenon I didn't hear or see before. And talking about the coil whine, it is very moderate on the card. It's pretty quiet, And I would say if you have this running inside a system, it will be very hard to hear, very hard to tell. So in general, the design when it comes to the Coil Whine is pretty good. Now after half an hour of torture test, this looks pretty good. We have a GPU temperature of about 44 to 45 degrees Celsius, which will heavily depend obviously on your water temperature. The water temperature right now is 28 degrees Celsius, but I think this is still a very good result from the previous testing that I have done with 5090s. I think this is a really good result when it comes to the temperature. The clock is always stable at 2800 megahertz, so there's no fluctuation, which is a good indication that the temperature and the contact to the GPU is pretty solid. It is still quite interesting that the reported power draw is lower than what it should be. It is 560 to 570, but we know that the card is currently always pulling about 600 watts. I'm not sure why this is the case, but it would also make sense if you think about that it's, at least according to GPU, currently always power limited, which wouldn't make sense at, I don't know, like 92 to 95% TDP. Now the WireView obviously gets warm as well, just by the amount of current that is flowing through it. You can see 64 degrees Celsius. That, yeah, I can definitely feel that. It is hot, but I can still touch this. And again, pulling just above 600 watts. The temperature in and out of the connectors is 60 and 64. That is also still in the green area. Even though it seems high, you can touch it and it feels really hot, but that is still okay. And after testing this, I would personally maybe set it to 80 or 90 degrees Celsius, because after half an hour at this temperature and now being stable, I would know that additional 20 or 30 degrees would definitely mean that something could be wrong, or at least would be worth to check for. If we check for TB, which is the backplate temperature, 42 degrees Celsius, I can also touch it, seems correct, and that is also a good result. I'm now repeating the 3D Mark Speedway, but not in the loop, so we can also see what kind of performance we get in this benchmark. And with this as a result, we get 149.4 FPS, which is about 2% faster than my RTX 5090 Founders Edition. And for full information, you can see that this card is running in PCIe Gen 5 x16, and I also didn't have any kind of issues with this card running Gen 5. The Coil Whine can be even less, because it just depends also on your frame rate and the condition. Now with Star Wars Outlaws, which is running with native rendering at a much lower FPS, and still causes the card to pull quite some current. We can see still about 600 watts under load. And if we now switch to a clip that was recorded, you will hear that you can not hear a lot. When it just comes to performance, temperatures, Coil Whine, everything seems to be really good. Now I want to inspect things further when it comes to how the cooler is built and how the entire assembly is done. One thing I already noticed by looking at the backplate the first time is the screw heads. I'm first of all not a big fan of the Phillips head, which, I mean, is subjective, but you can also see how the heads are all a little bit damaged. And you can also see by how they are damaged that they were damaged by, tightening the screw. It's not from opening one, and that's just the nature of the Phillips head. Could definitely be better if they used a hex or like a Torx head. We're now first removing the backplate. On the backplate we have those thick thermal pads. Interesting, the choice to only have a frame here and not cover the entire GPU area. I mean, we know that the temperatures were good, so that doesn't seem to be a concern. It's just interesting from my perspective that they went for just having a frame instead of covering the entire back of the GPU. Now the water block is only still held by these two screws, which again look like, the heads. They look like they've been through something. It's not really a technical problem, because if you would buy this card, you would probably not want to disassemble it yourself. It's just something that I noticed. Here we have the INNO3D PCB, which I think is the reference design or reference layout. I'm not quite sure. Either it's very close to it or it's exactly the same. And you can also see how the GPU was mounted on the block with one of those phase change pads, and also the imprint on the GPU looks good. Same thing on the cooler side, nothing unusual, everything looks good. We see thermal pads on left and right for the power stages on the GPU and also the bigger ones for the memory. On everything we can see a good imprint, so we can be sure that the contact towards the components was decent. Also for the tiny parts right here for additional power stages, and then finally the contact patch in the center for the GPU can clearly see, you can even still see the NVIDIA marking. And yeah, I mean, we know from the temperatures that everything was all right. And yeah, it's a very good imprint. Similar to the previous generations, this is overall a very good product, I would say. If we start looking at the card, it is not a special PCB design. However, it is a little bit shorter than other cards, which I think is good. And for me personally, the most important part is the very low to not existing coil whine. That is something I absolutely appreciate. When we look at the cooler, it's similar to what AlphaCool delivered before. It's a good looking block with good surface finish. We see good imprints on all the surfaces, may it be the GPU, memory, VRM. Also the temperatures looked good. The only thing that could be improved from my side are the screws and the screw heads that looked a little bit damaged. That is something I would not expect from a product in this price range, but it's a tiny little detail and something that can certainly be easily improved. And apart from that, I think overall a good product. If you're looking for a pre-assembled card that comes with a water block and warranty, I think this is a very good choice. I reached out with my feedback to INNO3D and they gave me this statement regarding the screws. It seems like they didn't use the correct bit for my sample, but it should be fixed for mass production, which is great. Alright, I hope you enjoyed this video. See you next time. Bye bye.